This is the second video I make, and on the first video I covered 1 through 7. We're going to cover the rest of the first questions, or first page on the second video, questions 8 through 12. However, I do want to go back and go over, because I saw the final exam, and like on number 5, they tell you factor completely, and of course you think what times what is the C value that if you combine together is the B value. You could make a list and you find out that it's -4 and -7, and that's your answer. Factoring completely, that's why you do it. But on the final exam, they're not going to give you the instructions factor completely. They're going to say, which of the following is a factor? That's the instruction they're going to give you, all right? So on your multiple choice, you are not going to see this as a multiple choice answer. They're going to give you something like this for the multiple choice. Like I'm going to say option A is G plus 4. Option B is G plus 7. Option C is G plus 1. And maybe they say option D, none of the above. So what's the correct answer? None of the above, right? So if they say which of the following is a factor, they're looking for either this one or that one. Okay, they're not going to put both of them. So I need to explain that to you so nobody freaks out when you read those instructions on the test. Factoring, this is how you factor, and this is the correct factored form, but you're not going to see both of them right here. You might not even see any of them right there, right? You're looking for either the G minus 4 or the G minus 7. The reason why they don't put this as option A is because then you could just say, oh, G times G is G squared, G times -7 is -7G, -4 times G, and you could figure out which one's the correct answer just by distributing as opposed to actually knowing how to factor. So they're going to give you one of the factors. They're going to ask you to identify one of the factors. They're not going to give you both of them. Another one that they might ask you, like normally when they say solve the system, we know that we combine the lines, we cancel those out, we solve for x, and then we take that x value, plug it back in to find the y value, and we get both answers, x equals 8, y equals -9. But on the multiple choice answers, they're not going to tell you to solve, or the instructions, it's not going to be solve the system. They're going to say find the y value of solutions, right? Find the y value of the solution. So they're going to just be looking for one specific answer, the y equals -9. And again, the reason why they don't give you both of these on the answer or both of these on the answer is because then you could actually just plug them in and see if it works. So they want to avoid the test generator, the test program. They want to avoid you just being able to plug in and get the correct answer that way. They want to see if you actually know how to get that answer, y equals -9. All right. So if you want to check that out, you could go and watch the first video if you missed any of that stuff. Right now, let's start with question 8. Question 8 is a quadratic trinomial equation. They want us to graph it. How do we start graphing parabolas? Step 1 is to find the vertex. So let's find that vertex using the vertex formula. X equals -b over 2 times a. And when we use the vertex formula, let's use parentheses, negative parenthesis over 2 times parenthesis. Of course, the b value is 5, the a value is 1, the c value is -1, and nobody cares about the c, it's not in the formula. So b is 5, a value is 1, we're going to end up with a -5 over 2. And I apologize, this is ugly. Why? Because -5 is not divisible by 2. I mean, do it on a calculator, what are you going to get? -2.5. You're going to get a decimal, right? -2.5, -2.5. And that is your vertex x value, -2.5, -2.5. Now we need to find the y value. Okay? How do we find the y value once we already know the x values? Plug it in. So we're going to take the equation y equals x squared plus 5x minus 1 and replace the x's with parentheses. That way we could easily plug in -2.5 in both of those parentheses. Now at this point, thank goodness that we have calculators. So here it is, ladies and gentlemen. I typed it all in exactly the way it is, and it gave me the fraction, the answer, -29 over 4. Now, if that doesn't make much sense to you, which to me it doesn't, I'm going to hit that SD button right there and change it to a decimal, right? If I do change that to a decimal, it ends up changing to a negative 7.25. Okay, so the y value is negative 7.25. If you have the other Texas Instrument calculator, go ahead and just divide 29 by 4, and you get the 7.25. Okay. Anyway, so our output is negative 7.25, and this is a very ugly location on the vertex, of the vertex. So let's go to that ugly location of the vertex. From the origin, I'm going to go negative 2.5, negative 1, 2, and then halfway to 3. And I'm right here in the halfway point. Now I need to go down 7.25. That's negative 7 1/4. So check this out. From this halfway point, I go down 1, 2, 3, 4, 5, 6, 7, and then 0.25 of the way down. It's really weird. Our dot's going to be right here in the middle. I mean, not in the middle, but floating around, not on a clean point. So let's put that coordinate right there, the vertex. It's right here. Really weird. The weirdest, right? We never did this on a homework assignment. Nevertheless, that's our vertex. Our axis of symmetry is going to be going right through it. And obviously, it's going to be a multiple choice test. They're going to give you 4 graphs. What if one of them opens down? What could you do with that one that opens down? You could cross it off because we know it's opening up. Now we know the a value is 1. It's difficult to do the 1, 1, 2, 4, 3, 9 with this because it's not at a clean point. So what I would do is just plug in one easy number in an XY table and then pull out the answer, and then that way you'll be able to identify which is the correct parabola of the 4 that they give you. So which is the easiest number to plug in when it's a standard form? Even easier than 1. 0. When you plug in 0, check it out. Your x is here, your x is there. When you plug in 0 there, what's your output? The c value of negative 1. So 0, negative 1 is a coordinate. It's actually the y-intercept value. So just by doing that, guys, you'll know that the parabola has to cross through there, and you'll be able to identify which one's the correct one. All right, just with that information, of course, you could, if you want, if you were graphing, you could map it over 2.5 this way, 2.5 that way. But this is your parabola, and since it's multiple choice, with that single y-intercept coordinate, you'll know which one's the correct one. Everybody cool with that? I hope so. Let's move on to number 9. Oh no, wait. There's more to state. How about the domain? X equals all real numbers. That's the domain. How about the range? Y is what? Greater than or equal to the y value of our vertex, which is negative 7.25. Remember that. The range is always y is greater than or equal to the y value of your vertex. How about the axis of symmetry equation? That's always x equals the x value of your vertex. What's the x value of your vertex? Negative 2.5. Okay? Keep that in mind, because they will be asking questions like that on the test. And of course, the y-intercept, we calculated that to find out the other point. So that's all you could ask about parabolas. Let's move on to number 9. Now, number 9, man, we got to go way back in time on number 9, because that's not a parabola. Anybody remember what kind of graph this is? Sorry, guys, we're not getting this. You see this power of x? It's an exponent, huh? The x is an exponent, and that should give you a hint that it's an exponential function, and it's either going to be an exponential growth function or an exponential decay function. This has been a long time ago that we covered this, so please pay attention right now. The b value will tell you if it's a growth or a decay function. All right, the b value tells you if it's a growth or decay function. So because, by the way, if you don't remember, y equals a times the base to the power of x. And usually there's, in Algebra 2, there's a minus h up here, and there's a plus k over here. But in Algebra 1, we didn't even do the minus h. All right? I hope we start remembering this, right? But the base tells you if it's a growth function or a decay function. If the base is greater than 1, it's going to grow. From left to right, it's going to grow. If the base is less than 1, like if it's a fraction like 3/4 or 1/2 or even 0.9, from left to right, it's going to decay to a certain value. Okay? So is this a growth or a decay function? It's growth. So just by knowing that, guys, you know that it's going to look something like this, like that, going up. From left to right, it's going to go up. Okay? And also, the k value is -5, which means that it has to the asymptote's going to be down here at -5. I hope we start remembering this. But let's pretend that we don't remember it. We'd have to use an XY table. And back when I taught you this, I said, do the parent graph first, ignore H and K, and then do the shift at the very end. Do you guys remember that? No? Okay, well, watch me, and hopefully you do remember. We're going to do an XY table for y equals 2 to the x. And we're going to plug in some easy numbers. 0, consecutive easy numbers. 0, 1, 2, 3, and also backwards, -1, -2, -3. Now, if I want to plug in 0, it's really easy. Plug in a 0 right there where x is at. What's 2 to the 0 power?
0.
Actually, anything to the 0 power is 1. And if you did it on the calculator, you'll see that it is 1. Okay? Now, what if I plugged in a 1 right there? What's 2 to the 1? What's 2 to the 1? 2. How about if I plug in 2 right there? What's 2 squared? 4. And how about if I plug in 3 right there? What's 2 to the 3rd?
9.
Nope, not 9. 8, right? 2 to the 3rd is really 2 times 2 times 2, which is 8. Are you with me? Now, we didn't actually have to plug in each and every one of these inputs. You could have said, plug in 0, get out a 1. This output, because we have consecutive integer inputs, this output is going to change according to that growth factor, that base value of 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. You didn't have to think of it that way. You could do it exactly the way we did it and recognize that it is doubling as you go, which means backwards you're going to be dividing by 2. So 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. Or you could think of it as multiplying by 1/2. 8 times 1/2 is 4, 4 times half is 2, 2 times half is 1. What's this value up here? 1/2. And then the next one, 1/4. And the next one, 1/8. And we know that it infinitely gets smaller, infinitely approaching nothing in that direction. So let's graph these blue coordinates. 0, 1 is right here. 1, 2 is right here. 3, 4 is right here. No, I'm sorry. 2, 4 is right there. 3, 8 is way up here on the edge. And in the other direction, -1 and half. That's -1 on the x, halfway up on the y. So that's right there. And then half of that's 1/4, and then 1/8, and 1/16, and 1/32, 1/64, 1/128, 1/256. We know it infinitely gets closer to the x-axis, but it never actually touches. That is our parent graph, ladies and gentlemen. But we still need to do a shift. How do I shift these blue dots? Down 5. How do I know down 5? Because of this bad boy right here, the -5. That means you're going to go down 5 units. The k value tells you whether you're going to shift up or down. In Algebra 2, yeah, whatever's up here with the x, you're going to be shifting left and right. But right now, Algebra 1 just has a k value. So we're going to shift all this graph down 5 units. So if it infinitely approaches this asymptote of 0, if you shift that down 5 units, it's infinitely going to approach the -5. So let's do that. Let's put our dots right here, 5 units down from the other dots. Let's go to the nice dot, this nice dot, and go 5 units down. It'll be right there. This guy right here, 5 units down, it'll be right here. And so on and so on. So if you shift every one of those 5 units down, you get to all those red dots. And then go the other halfway, the 1/4, the 1/8, and so on and so on. So our final graph is this red one, not the blue one. Now, this took a very long time. But on the test itself, you're going to have 4 possible graphs. All right, 4 possible graphs. So what if you had like this guy looking like this? You would say that's impossible because that's a decay function. And we know that this has the base of 2, which it makes it a growth function. So this one can't be it, right? So from left to right, it has to grow. So what if you see something like this? You're like, yeah, that's growing. Okay, that's good. But this one has a k value of -5, which means that it can't have an asymptote at 0. It has to have it at -5. So the actual multiple choice test is going to be a lot easier than what we just did. All right? Cool. What else? Let's state some additional information. What's our domain right here, guys?
X equals all real numbers.
That's right. Is that just because the parabolas have x equals all real numbers? This is not even a parabola.
No, it's because that's how it is.
That's how it is, because it does go to the left forever, and it does go to the right forever. Even though it looks like it's going up, it never goes straight up. It keeps going this way forever. Okay, so yes, x equals all real numbers. Now how about range? The range of your y values, this one's interesting. Is this red graph above, is it above a certain value or below a certain value? It's above the value of what? Negative 5. So what am I going to put? Y is greater than, it's above negative 5. But notice that I did not put greater than or equal to. Why not? Because it never actually equals negative 5. It infinitely approaches negative 5, but it never actually touches negative 5. So keep that in mind as well. That's about it, unless I ask you to find the y-intercept. That would be that location right there. Let's move on. Number 10, solve. It's a quadratic equation. The best way to solve this quadratic equation, or any quadratic equation, is to set it equal to 0. And then factor, split, and solve, or use the quadratic formula. I want to subtract 84. Subtract 84. Obviously, you can't subtract 84 from anywhere, so I'm going to rewrite the whole thing. K squared minus 5x minus 84 equals 0. And now I can identify the a value of 1, the b value of negative 5, and the c value of negative 84. So it is totally up to me, or up to you, whether you want to try and factor k right there, and then split it and solve it, or you might want to use the quadratic formula. It's totally up to you. Now let me tell you this right now, some great advice. On your multiple choice answers, if you see a bunch of multiple choice answers that have something like x equals something plus or minus the square root of something divided by something, use the quadratic formula, because that's how it ends up looking, right? If you end up looking at your answers and they're all nice answers, like x equals 3 and 4, negative 2 and positive 7, or 1 and 1/2, then you know you could actually factor it, split it, and solve it. So let's try to factor here. We could use a calculator. How could I get negative 84? Negative 1 times 84. Negative 2 times 42. Negative 3 times 84 divisible by 3 with the calculator. I don't know. Let me see. 84 divided by 3 is 28. Negative 4 times 21. Negative 5 doesn't work. Negative 6, 48 divided by, 84 divided by 6. You guys could help me if you want. 7, does 7 work? Yeah, 84 divided by 7 is 12. So negative 7 times 12. Woo! And that is our pair of numbers that we want. If I add negative 7 and 12, what do I get? I get 5. Wait a minute. I don't want 5. I want negative 5. So I have the right numbers. I just have the wrong signs. Change it to a positive 7 times a negative 12. You with me? Okay. So put a plus 7 there and a minus 12 right there. So we have factored. We still need to split and solve. Man, maybe it would have been easier to do a quadratic formula. I don't know. But anyway, if you have something times something and you get 0, the zero product property allows you to split those somethings and set them each equal to 0. So I do have k plus 7 equals 0, and I have k minus 12 equals 0. And if I solve both of those, I'll get k equals negative 7 and k equals positive 12. Those are our two answers for number 10. I hope you're satisfied with that explanation. Let's move on. Number 11, write the equation of the axis of symmetry. Okay, here's a big detail, guys, that you guys need to know. The axis of symmetry is going to be x equals what? The x value of your vertex. X equals the x value of your vertex. We don't know the vertex yet. Let's find our vertex. How do we do that? X equals negative b over 2 times a. So negative parenthesis over 2 times parenthesis. The b value is 8. The a value is 6. The c value we don't care about on this formula. So you have an 8 right here, and you have a 6 down here. So what we really have, ladies and gentlemen, is negative 8 divided by 12. And I could reduce that. Can't divide, but I could reduce by 4, and I will get negative 2 over 3. So what did I just find? I found the x value of the vertex. If I wanted to find the y value, all I have to do is plug in that x value to solve for y. But I don't need to find the vertex. They're not asking you to find the vertex. They're asking you to find the axis of symmetry. And we know that the axis of symmetry is the x value of your vertex. So we already have that. So it's x equals negative 2/3. That's your answer for the equation of the axis of symmetry. That's the vertical line. And on the test, it will be a fraction just like it is right here. Number 12. We could use a quadratic formula. Again, look at your answers. If you end up with two nice answers on your multiple choice, none of them have the plus minus square root over a different number, then don't do the quadratic formula. Try to factor, right? Unless you want to use a quadratic formula, it always works. But right here, I'm going to do that multi-step process of factoring. Step 1 is to multiply a times c. A is 3, c is negative 10. I get negative 30. Step 2 is to think of the multiples of that answer, negative 30, like negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 4 doesn't work, negative 5 times 6. Those are all the possible ways of getting negative 30. And you want to see which pair of numbers combines together to give us the middle value, b, which is negative 13. So if I start combining numbers, a lot of people make the mistake and think, oh, 10 plus 3 is 13. Right there. When you go 10 and negative 3, that's 7. That's obviously not 7. It's this guy right here, negative 2 and positive 15. When you combine those, you will get 13, not negative 13. So we have the right numbers. We just have the wrong signs. So instead of a negative 2, let's make it a positive 2. Instead of a positive 15, let's make it a negative 15. So this is the correct pair of numbers for step 2. Does anybody remember step 3? Step 3 is where you set up your parentheses and you put an AX right in there. What is AX? In this case, it is 3X and 3X. Remember, A and X. So AX, which is 3X in this case. Now, what do we put in those blank spots? The negative 15 and the positive 2. The positive 2 and the negative 15. All right, so we have done step 3. Step 4 was that magically divide each binomial by whatever you can. So step 4, I can't divide anything on the first binomial, so I leave it. And the second binomial, I could divide both of those by 3, and I'll get an x minus 5. So I have completely factored this quadratic trinomial. After that, it's still set equal to 0, so I still need to set this factored form equal to 0. So that equals 0, I'm just going to slap it on right here. And then I could split it and solve it, right? If you have something times something and it equals 0, the first something could be 0, and the second something could also be 0. If I solve this, minus 2 right there, I'll get 3x equals negative 2. I divide by 3, and x equals negative 2/3. That is one answer. The other one, simple, plus 5, x equals 5 is the other answer. And that's about it. Now, I don't know, that did take a long while. Maybe the quadratic formula is faster. But either way, you'll get the right answer. The quadratic formula always works. Sometimes you're not able to factor. But again, look at your answers to give you an idea of whether you need to use a quadratic formula or not. We'll start number 13 on the next video.